this is T eating her first Reese's peanut butter cup of her life. Oh! Oh!
What do you think?
Did you eat it? Big bite. What do you think, T? Tell us what you think of your first Reese's peanut butter cup.
Too sweet.
Too sweet. Oh, quit it. Those guys. They're too sweet. Now, the other one, what we'll have you do is try to eat it the proper way. Inside out. It is possible.
No, it's impossible.
No, I disagree. All right, T, you are the first 45 seconds of video on the blog now. Hey, everybody. Now, we're going to go through a review real quick. I got the...
yeah, I'll work on it.
I also got the answer key on the blog.
Oh, I got this.
Now, for the weekend, we have a quiz on Tuesday. The worksheet that is on the blog, it's on there, is exactly the same minus, obviously, numbers. All right, let's go. We're going to go fast. So if I go too fast, slow me down. Stop me. Otherwise, I'm going to roll. Okay. How do I write this as a fractional exponent or a rational exponent? Power over root.
4 over 5.
We're going fast. I need you with me. Here we go. 17 to the 2/5. How do I write it as a radical?
5th root. 17 squared.
Power over root. What's this equal to? 81. Done. This will all be on the blog if you don't get it written down. How do I do this? Power over root. I'm going to write these squared even though you don't need to. What's the square root of 36? 6. What's 6 to the third power? 216. Good job. How do I solve this? Subtract. Cube root of 125.
5.
Do I need plus minus, yes or no?
Yeah.
No! Good job, why not? Because it's odd, and you can't take a negative times itself 3 times. 3 negatives make a negative. Where are there more 4s? Top. How many more? 1 what? Third. Some people would write it this way. I would probably go a step further and write that. It's up to you. I just don't like fractional exponents as my final solution. That's me. Hunter, I will never count it wrong because you're right. And since you're drinking Red Bull, I'm sure that you'll be excited to do this here in a few minutes.
So for 8, you subtract the exponents and leave the 4?
Base number doesn't change. It's a shortcut. Now, ladies and gentlemen. Hello? I'm in class. I'm being videoed too. What do you need, babe?
He's almost in like a Hail Hitler stance.
I would assume so.
Cool, you know you can move your arm. Yeah. There you go.
All right, bye. Okay. Ladies and gentlemen, take a look. Here's the most awesome thing in the whole wide world. A lot of you would go, I don't know what to do there, and I maybe take 2 to the 1/4. No. Reduce. 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 Oh, Daff, your eyes are open. Good. So if I reduce this, what's 4 through to 16? T, tell him. 2. Now, ladies and gentlemen, oh, you'll see my X through from the last period. But this is 27. Why did I draw an X through this? Because there's no reducing. This is weird. What am I going to do? Jordan, you know, don't you? I knew it. He said, take 27 and rewrite it with a really small base number. What's he mean by that? What's another way of writing 27? Harding's going, what the hell is he talking about? 27. Is there other ways to say 27? If you were dating a 27-year-old, Harding, you know what you could do? You could tell your mom and dad, I'm dating a 3 to the 3rd power guy. What are you talking about? Well, your parents would go, what? Unless they're mathematically gifted.
They're not.
Well, they could figure it out, I'm sure. But I have a lot of students whose parents can't figure that out. I get it. So, ladies and gentlemen, why do I suggest doing that? Why do I suggest doing this? Anybody? It will save you tons of time. Tons of time in solving this. All I did was rewrite 27 as 3 to the 3rd. Now, as I keep moving, this is where I go to my fractional exponents. No fractional buts. What am I going to multiply the bottom by so that I don't have that fractional denominator, fractional exponent? Say it out loud. 3 to the 2/5. What is 3? Base numbers are the same. What do you do with your exponents? My good friend? Adam. What's 5 over 5 equal to? 1. So I have 3 just on the bottom. Now here's where everybody gets confused with me and my process. Fifth root of 3 squared. So I took the fractional exponent and wrote it as a radical. Now, I'm going to, where's my... Do you agree that this is also the same as that? They're both inside the same radical, aren't they? What's 5 times 3 squared? 45. There's my solution. That by far is the second toughest problem up here.
Which one's the hardest?
Next one. Yeah.
Do you write it as a fractional radical?
I mean, you can.
I mean, so I can see.
Oh. So you want to see it as 5 to the 1/5 times 3 to the 2/5. Base numbers are different, so I got some work to do. Harding, stop being so negative.
Take 2 away.
I'm not being negative.
Yes, you are.
No, I'm not.
Your tone is, then. Your words might not be. Thank you.
You're welcome.
Yes, ma'am.
Where do you get the 2 from?
Which one? This?
Yeah.
I have a radical butt.
Okay.
Okay? So if I multiply, I wrote it as a fractional exponent. Okay? So I took the same base number, and when you multiply exponents, base numbers with exponents, you're just adding these two together. So I'm looking to get rid of that fractional exponent. That's a radical to me.
Okay.
Radical denominator's bad. So 3/2 plus 2/2 is
A whole.
5/2, or 5/5. I didn't say anything right there. 3/5 plus 2/5 is 5/5. 5/5 is 1. So that gets rid of my fractional exponent.
Would you need 4/5 of that?
No, you're just multiplying it. Because you're not going to get
These are different base numbers. You can't combine them. Yeah. Let's look at K real quick. 81, does it have a perfect cube? Yes or no?
No.
Huh. You know what? How about we reduce first? Where are there more X's? How many more? Where are there more Y's?
No, I got this.
Where are there more Z's? What you gonna do here now? Is there a cube root of 81? Is there a perfect cube that will divide into 81? Let's try that.
No.
Yes, there is. What is it? Well, 2 times 2 times 2 is 8. Does 8 go into 81? No. 3 times 3 times 3 is 27. Does 27 go into 81?
Yeah.
Yes, it does. So, if I'm simplifying this, a 3 could come out. It's beautiful. And I'm left with 3x inside. Hunter, you okay with that?
I just don't understand, like,
Perfect cubes? Do you know what 2 times 2 times 2 is? That's a perfect cube. You know what 3 times 3 times 3 is? That's a perfect cube. You know what 4 times 4 times 4 is? 64. You could probably figure it out if you take a moment to think, huh? 64, guess what? It's a perfect cube. So, 27 times 3 is the exact same as 81. Agree? What's the cube root of 27? 3. It's perfect. Show it off. Young.
Okay, back to the last one, why can't you size different base numbers? Like the 5 and 1/5.
So what were you going to do? Let's say you know what 3 squared is, right? Do you know what that is? I'm going to go to a whole different problem here. Okay? Do you know what, so you know what 3 squared is 9, right? And you know 5 squared is 25. So, what's 9 quarters? 225. Agree? So, your method that you're thinking of right now, that would be 15 to the 4th power. Is 15 to the 4th power the same as 225? Yes or no? It isn't.
No.
So then mathematically, you either have to convert those to get rid of them or you have to keep them separate. You can't just multiply different base numbers with exponents and just add them. I don't know if I made any sense to you. We can't multiply those because they're different base numbers and they have exponents both. I either have to simplify them into the... Now, once they're in the radicals, once they're inside the radicals, sure, now I can do it, just the top numbers. So, 5 times 3 squared. But it still stays inside the radical. Okay? Anybody? Hey, Hunter, what's the cube root of 8? I asked you first. What's wrong with this problem? Radical butts, can't have them. Joes, I know, I'm getting pissed too. So, ladies and gentlemen, you don't have to worry about the top. You can have anything on top and make it look good. It's your bottom. So, let's just focus on this bottom here. So I have 2, and I'm going to write it this way. Is that okay? What do I have to multiply to get rid of this fractional exponent? YZ to the what? 2/3. What you do to the bottom? So, this gives me what? YZ. I still have my 2. So on the bottom, 2YZ. Here's my top. I'm going to have a 3. Cube root. 3. How many x's? How many y's? How many z's? Because they're both squared. That's by far the worst, nastiest problem that I will give you. I sure hope so. Okay, well, since Howard asked for it with the please, yes, it's on there.
Why would you punch me then? I just got it out of it.
It's on there.
Oh, then why would you do that?
Because you asked for it. It's already made now.
Why you punch me? I'm like,
T, you should be an expert at this now that you're a Reese's peanut butter lover. Start on the inside. Work your way out. F function. I'm going to take 3 times 5 minus 8. Now I'm going to go back to the same function. 3 times 7 minus 8. Again, inside out, inside out. How do I do that? Oh, we got to do this one. K of x is the same as 5x minus 2. Now I go to the H machine. H function. 4 times 5x minus 2, negative 1. How do I make an exponent happy? Move it. Now, here's the $1 million question. If you had 5 more seconds to give me, this is it. What's the domain? Do you remember what domain deals with what letter? X. And I think I made the statement, domain isn't always what it is, but what it ain't? Sure. Or isn't. Do you remember that? Because remember, what can you not have in a fraction? Zero. There's a lot of things, but you can't have a zero but. What would cause me to have a zero but here? How do I get that? If I want to find out what would make that equal to 0, well, set it equal to 0. That's how you find things out. Add 2, divide by 5. Now, ladies and gentlemen, domain, if you remember earlier this year, I believe. Nope, we will here soon. Domain can be all real numbers. It can be lots of things for x. X can be any number, but it cannot be. That should be 2/5, you dork. Why didn't you tell me, Howard? Point taken. X cannot be 2/5. Why can x not be 2/5? Because you have a 0 in your denominator. How many of you take physics? Didn't they say that 1 over 0 is equal to the black hole? That's how they define it. I heard that. I don't know if it's true. Huh? Is it? Well, I think you'll find out tomorrow. Oh, no class tomorrow. Yeah.
Going back to this A, I thought we got rid of the Q group and that you couldn't have like where you circled it on the blue part right there, like on the bottom. I thought you couldn't have the Q group.
I didn't. That's why I came down here to show you. I moved it to a fractional exponent.
Yeah.
And then I multiplied by yz to the 2/3, so I just end up with